Welcome to Study Loop.
So, number of students in the class is 200. Heat generated by each student in 1 second is 130 watt, and time of lecture is 50 minutes. So that is equal to 50 into 60 seconds. So that will be equal to 3000 seconds. So we can easily calculate total heat generated by 50 students in one lecture time by using the relation Q equal to heat generated rate by each student into time of lecture into number of students. Here P that is generated rate by each student, which is 130 watt, into time of lecture is 3000 second, into number of students is 200. This gives us total heat generated by all students is 78 double zero double zero double zero joule. Now by using the relation Q equal to N, that is number of moles, into molar specific heat at constant volume into change in temperature. By using the relation, we can easily calculate rise in temperature of air inside the classroom. As by using ideal gas equation, we can write Pi Vi is equal to nRTi. Here Pi is initial pressure inside the room, Vi is initial volume, and Ti is initial temperature inside the room. We can write N equal to Pi Vi upon RTi. So, and here Cv, that is equal to 5 upon 2. Now by putting the value of N and Cv in the relation for Q, so this will give us Q equal to, here N is Pi Vi upon R into Ti, and Cv is given in the problem, which is 5 upon 2 R into delta T. So here R and R will be cancelled. So this gives us change in temperature equal to 2Q upon 5 into P initial into V initial. Now by plugging different values in the relation, delta T equal to 2 into here Q, that is total heat generated by all students, which is 78 triple zero triple zero joule upon 5 into initial pressure inside the room is 1.01 times 10 to the power 5 Pascal into initial volume of air inside the room, which is 1200 cubic meter. This gives us delta T equal to 75.5 75.5 Kelvin. So this is the rise in temperature of the air inside the room.